Dear customers and partners, our valued SCIA enthusiasts, I am thrilled to be here with you today, as this is my first release since I became Director of Product at SCIA. And it is with great honor that I welcome you on behalf of myself and the entire team to unveiling SCIA Engineer 24. Our commitment has always been to maintain a continuous dialogue with our users, ensuring our software evolves to meet your needs. Today, with SCIA Engineer 24, we are proud to showcase our dedication through the new features and developments designed to enhance your workflows and elevate your productivity. With this release, a new milestone has been achieved, marking a significant advancement in enabling you, our customer, to accomplish exceptional design. We have tackled multiple axes. The first axis that we tackled is productivity, by offering one version of SCIA Engineer and a revolutionary unique user interface. The second axis, and it is an important one for all of our users, is analysis. SCIA Engineer 24 is the culmination of years of work by our development team to introduce a completely new solver manager. This breakthrough not only optimizes the calculation process, but also enables more advanced analysis. Moreover, SCIA Engineer 24 introduces a variety of additional improvements, including license management, refined user interface, optimized input and modeling functions, and enhanced code design capabilities across different materials. Over the course of the next hour and a half, we will explore these features in depth, demonstrating how they can improve your daily work. And for those of you who would like to be in contact with us and help us build the future SCIA Engineer, stay with us till the end, as we will highlight our product portal and tell you how you can help us shape the future roadmap of SCIA Engineer. Following our presentations, we invite you to engage with our experts, who will be available to answer any questions you might have. Let us now embark on this journey together and discover how SCIA Engineer 24 can elevate your engineering game.
Good morning, everyone. Good morning from my part. I'm very delighted to host the very first online conference here in Hasselt from our headquarters of SCIA. This one here is marking the grand release of SCIA Engineer 24. Thank you very much already now for joining this conference, where we introduce you to the new SCIA Engineer 24. Let me quickly introduce myself. My name is Joel Ricker. I'm the CSO of SCIA, responsible for the global sales activities here at the company. I will be your guide within the next couple of hours. Actually, you see, we are really live. So what you see in the background, as I told already, this is our headquarters. We are here in Belgium in our headquarters, in our office. You will see all the features and details of our new setup and of our new version that we are launching at the moment. I see we have difficulty. We still have some technical issues. Is everything solved? You see, this is alive, so there might be some issues up front. I think everything is solved. So we are continuing. So get ready to explore all the new features and new functionalities that we have launched now, along with our experts that I'm presenting right now to supercharge your productivity. So let me give you a small structure for the next 2 hours. I will share 3 steps. First, we will give you some insights on how to use the innovative products and software tool, all the innovative upgrades in your day-to-day, and actually how you can increase your productivity in the daily business. In the first session, this is our Director of Product, Judd, that you already know now, who will give a short presentation, and this will be followed by Marco Di Biasio, who will give a quick demo of it. Second, you know, all the new functionalities and all the features that you have seen in the past, this is fueled by your feedback. So your feedback is very important for us. And Our dear colleague Yael Kakama will shed a light on how your valuable input is shaping our software. Third, we will have our dear colleague Manuel Walter with us, who will give a short introduction on how you can seamlessly upgrade your foundation calculations, combining SCIA with our second tool, Frilo, to increase your productivity for the foundation calculations. And actually, I will just add one comment from my side. Please don't hesitate to add comments or ask questions in the chat. So we have prepared the chat. You can just put everything in you want to know, and we try to answer as best as possible already within this session. So this will be your opportunity to get the first answers. But of course, we will answer to all the questions that you raise up here in the near future. So first, my dear colleague Judd, who is just next to me somewhere, will give you an introduction on how you can elevate your engineering game with the new version of SCIA Engineer 24. Enjoy.
In this presentation, I'm going to highlight the biggest improvements for SCIA Engineer 24. I must admit, I'm very proud to be the one presenting you this release, as this version, this SCIA Engineer, really sets itself apart from any other version, any other release we have done so far. It's a really big leap forward in terms of boosting your analysis and boosting your productivity. Let's see together now how this version, SCIA Engineer 24, will elevate your engineering game. We aim to maintain a continuous dialogue with our users. Today, we will showcase this commitment by introducing this release and the major axes that we have worked on. The first axis that we have tackled is the analysis part, a new solver manager bringing new possibilities to you. But it also allows us to enable new features for you in the future. The second axis is productivity. With one user interface and having one version, making your workflows better and simplifying your daily work. That is not all. Building on these two axes, we aim to elevate your engineering game with many new features and enhancements that I will proudly showcase to you. Let us start with the analysis part. Analysis, as you may know, is an integral part of our software. It's a very important one. This is why you chose to buy SCIA Engineer, because it enables you to design your structures, any type of structures. In the last years, many of you have asked us to boost our analysis capabilities. And this is normal, with structures demanding more and more advanced options, advanced calculations, and asking for more and more precision. Let us see how we answer these challenges. Our development have been working for the past years on a new solver manager. What does it mean exactly? Well, it means a better handling of data of the preprocessor and the solver. Okay, this is technical, but what does it mean for you, the user? It will mean faster calculation speed. It will mean advanced calculation options and new features. And it will mean that you will have more control on your calculation. How? Let us see. The new solver manager will be faster by allowing parallel computation. This parallel computation will allow you to fully exploit the power of your machine. We know that new laptops, new computers are more and more powerful, but you cannot really benefit from this power, and we want you to benefit from it. This is why we have parallel computing now. With this new feature, we could witness an improvement in the calculation speed of up to 5 times faster. This is a real game changer and a significant improvement. As you can see by the screenshot that I have here on the left, multiple nonlinear calculations are running in the same time on the same machine, and this will change your calculation. We even saw big projects that used to take hours to calculate, and sometimes we really needed to split the projects because we had more than 400 nonlinear combinations. This is no longer the case. We can run the same project on the same machine in really 10 minutes, winning enormous time. With parallel computation comes a new dialog for calculation. We have decided to implement also with the new solver a completely new dialog for the calculation, of course. This dialog will give you more control during the calculation, allowing you to stop the calculation in one click, for example, saving you the need to wait for the full analysis to run. And sometimes with nonlinear combinations, it could take a long time. So you can now simply just, with one click, stop the complete analysis. Not only that, but we also introduced completely new warning messages that will allow you to know exactly what's going on with your analysis. So it will give you immediately the result if the calculation was successful or if there's an error in a certain nonlinear combination or in a certain stage, for example. Besides that, we all remember our unique singularity window that pops up in case of instability. Of course, it's a great feature and we're keeping, but we also notice that sometimes when it pops up automatically, it was a little bit disturbing for our users. Now, we still have it, but it will no longer pop up automatically, but instead it will be really on demand by the user. Okay, all of this is great, but what does it really bring in terms of new calculation, new advanced analysis options for these users, you might ask? In response to the market and in response to projects needing more and more accurate analysis, in response to building the different stages in a certain structure life cycle, we have, of course, a big new type of analysis that we needed to also implement, which is the construction stages. In SCIA Engineer 24, we are proud now to have redeveloped and reintroduced the possibility to add and run construction stages analysis, allowing you to have more accurate calculations for your structure, whether it's bridges or buildings. This feature will really allow you to have more precise analysis. This new feature is completely redeveloped and is now, of course, possible in 64-bit, but not only that, it will also be in the new user interface. So what is now possible with construction stages? It's possible to add and remove not only 1D elements like in the past, but also surfaces, so 2D plates. It's possible to add them and remove them freely. You can also add and remove cables and pre- and post-tension tendons. A new feature is also the possibility to add and remove all types of hinges. And of course, you can add and remove all types of supports. Okay, another big improvement that we have introduced now in the construction stages is the possibility to have phased cross-sections. As you know, this feature we had it before, yes, but it had some limitations. We have now removed all these limitations. So you can add, for example, a stage cross-section with absolutely no limit on the number of stages. Before it was limited to 2, for example. And now you can, of course, do it without any limit on the stages. Not only that, but we also have the possibility now to remove a certain part of the cross-section, but also we can re-add it and activate it later on a different stage. Besides all that, we now have the possibility to change the characteristic of the material. by adding material modifications, for example, in a certain construction stages. And this modification or this factor will modify the E-modules in the construction stage. This will allow users to take into account long and short-term characteristic of concrete, for example, and the possibility to account for creep through a normative way through equivalent coefficient method, a method that is also described in the Eurocode. Okay, analysis is great, but we also want our users to increase in productivity. That's our aim. Faster calculation is a big boost and big improvement, of course, but we also want you to have a smooth workflow. We want to make your journey easy, and that's why in SCIA Engineer 24, we will have one interface and one version, and that's of course 64-bit. 3 years ago, SCIA Engineer set itself apart by releasing a new user interface. And when we said new in the past, we really meant completely new, completely redesigned. It was the result of years of research and development. Now, after 3 years, we are proud to say that more than 85% of our users are using the new user interface. And not only that, we constantly receive great feedbacks and excellent ratings thanks to its user friendliness and the possibility to customize it to your needs. So what we have worked on this year is multiple facets in order to improve this productivity or your productivity. So of course, by having one version and one interface, but how did we tackle it actually to meet your expectations? We focus on the overall use of the interface. We made the interface more stable, more responsive in a way that you will really enjoy using it. We improved the workflows and we improved also the license management, which I will describe later on. Now, I will mention some of the features. I will not highlight everything because another part of the presentations will be followed, or my presentation will be followed by the presentation of my colleague who will show you in the user poll what other improvements you have voted for. When using SCIA Engineer 24, you will immediately notice the difference. Not only it runs smoother than ever, but you will really enjoy designing your structure thanks to the many improvements that we have in the interface. To name a few, but not only, the improvements are in the process toolbar, for example, which will have a better drag and handle. Another improvement, especially for the new users, is new templates. And we implemented new templates by type of structures. So if you design, for example, a steel structure or a concrete structure, you can upload these templates, you can activate these templates, and that will allow you to get started with SCIA Engineer with a pre-configured interface that you can, of course, later on customize as you see fit. And because licensing is important, we have also introduced new improvements for license management. We have an improved license handling system, and we have improved the warning messages in case, for example, a user is trying to block or use multiple mandatory licenses. There's a warning that will pop up telling him that this is the case. Okay, so all of this is great, but we thought that maybe it's just not enough. And we really want you to elevate your engineering game. So we decided to build on the previous two axes, so productivity and analysis, to include new features that were redeveloped or improved to really help you elevate your engineering game and help you design the best structures. Let's see those features together. One of the big new improvements is the possibility to have new nonlinear analysis for reinforced concrete structures. What does it mean? So we have really introduced a new nonlinear behavior for reinforced concrete structure. So you can now compute with this nonlinear behavior, and this will allow you to model existing structures and really be able to see the impact of time on these concrete structures. This will definitely enable you to model more precisely and more accurately any structure you want. Now, you might say that we had this feature in the past. True. But exactly like we did for construction stages, we did not re-implement, we improved. So if you remember in the past, we had the support of nonlinear analysis for 1D elements, so beams, and it needed to be in 2D environment. Now, we not only support it for 1D elements, but we also support it for surfaces, so 2D. And not only that, but you can use it for a full complete structure in a 3D environment. So really you can do this kind of analysis on your complete structure. Not only that, but it will also support, of course, general plasticity, and it will support the new the Mazar's law with or without tension, for example, for resistance. With or without tension resistance for concrete, and elastoplastic law with or without kinematic hardening for steel. Another nice improvement is our new code-dependent deflection analysis, or what many of you know it as CDD. It is a feature that is widely used by our users, and it is really one of our unique selling points for concrete structures. So what is new exactly about it? As you know, code-dependent deflection allows you to get the result or to calculate the deflection in concrete, taking into account creep and cracks. And of course, it's a mandatory check, we'd like to note. So what is new? With this release, CDD is more powerful, more accurate than ever. It will support nonlinearities, all types of nonlinearities. It will take into account hinges, which wasn't the case before. It will take into account eccentricities. It will take into account model modifiers and orthotropy. And it will allow you to get the results according to local coordinate system and the global coordinate system. With this, you can model and analyze your structure more accurately than ever as well. A small improvement for our concrete fans is the second order improvement for concrete. This will allow now users to choose between three methods: nominal stiffness, nominal curvature, and the general method. And it will allow you two input possibilities: the creep ratio and the C parameters. Other improvements are the automatic mesh refinement, improving the way results are generated and giving you a better output. Another big improvement also is the automatic signing of RSA results for seismic load cases, a feature that has been requested by many users. Why? Because we have noticed that not assigning the results was the number one mistake that users used to make. Now, this is an automatic process. Other small improvements included in V24 are easier conversions for complex structure due to a new setup for nonlinear analysis, and the possibility now to visualize global imperfection, allowing the user to double-check that the global imperfection inputted is correctly taken into account. Last but not least, some additional improvements for an important segment of our users, scaffolding. There has been an improvement here on how the handling of the interaction for the layer types of scaffolds. We have also improved the handling of zero resistance for couplers. We updated the Zola Song documents to the latest version. And we also did an update for the ArcelorMittal catalog to include all the latest cross sections. And with this, I reach the end of my presentation for today. I really hope that you like what you see and that I managed to get you a little bit excited to try the new version of SCIA Engineer. You might ask me, when will this version be available to download? It already is on our website. So please go ahead, download it, and try it. I'm positive that you will enjoy using it and you will really have a blast designing your structures with it. It is by far one of the best versions that we have released so far. This is not all for our conference today. Stay with us till the end, as my colleague will also present other new features that you have voted for in our customer poll. Thank you.
Now we know some exciting news, of course, and we have learned about the first major changes and news, of course. But let me ask one question. So, dear partners, you as well, you might have heard about the merger. This is exciting news for everyone. Now we have merged Altran, SCIA, Frilo, and TC to one huge company. Can you tell us a little bit more about this merger? What does it mean for the users, etc.? So maybe you have some responses already now.
Yeah, of course. So this is hello everyone again. But of course, this is really exciting news. We have decided at the beginning of this year to really merge and combine our forces. So Allplan, SCIA, Frilo, and DC will join together and form one big organization. Now, this will enable us to innovate and be able to really change the complete workflow from design to build for our users. Of course, we were all sister companies. We all belong to one big family, which is the Nemetschek family. But we're taking a little bit step further. Collaboration always existed, but it's different when we are really one. And we tackle the challenges that you, our dear customer, face as really complete workflow. So instead of looking at it as structural analysis, detailing, architecture, each as a separate piece, we would like to really combine the puzzle and to look at the big picture and to be able to really bring innovation, really change the way the complete workflow is, and really look at it as an ensemble, as in a whole, in a general view, to really unite forces and break down these silos where each is working separately and really bring in collaboration to your workflows. And that's why I think this merger will really enable us, it will help us to empower you, our dear users.
Okay, yeah, thank you very much. That is a good, precise answer to that. I hope that helped you to get a better transparency and a good picture of those facts. But actually, thank you very much for all the questions that you raised in the chat. In the meantime, I got two of them, and maybe you have an answer to those. I just picked two. One is asking, like, can I still use the old interface? I assume that the question is about the user was using the old interface, now moving to the new version, but having the wish to use the old interface. That's my interpretation, but I think it might be the right one. Maybe you have an answer to that.
Of course. So, as I said in my presentation, SCIA Engineer 24 will only have the new user interface. So, and we made this decision in a way to be able to bring in more new stuff, bring in new features, be able to concentrate on one user interface to improve your workflows and to really streamline it. But we really did it because we received great feedback. We already see from the data from the users that more than 85% of our users are using the new user interface. And with the version 24 and the new features that we will have, this number definitely will become more and more and will increase. And that's why we decided to stop with the old user interface and really be able to show the benefits of the new one versus the old one. We have constant reviews, constant feedback that customers who have made the step and started using the new user interface really have witnessed an amazing increase in productivity and really were able to accomplish more in faster time.
Good. Okay. Yeah. Thank you very much. Good. And now I picked the question because it's somehow asked several times. When will the download, and I assume the download is meant to be the new version SCIA Engineer 24, when will the download be available?
Well, it's a simple question. You can already go on our website and download it. So version 24 has been already published today, this morning. Big thanks go to all the development team, product team, everyone from support to sales. So all the organization really, I know everyone put a lot of effort in it. It is already available, so please go ahead and download it and test it yourself.
Good. Great. Okay. Thank you very much, Ed. So, for this part, after the first part, it's always time for the second part, and this is now. Actually, we have our dear colleague Marco from your team with us, showing us a bit more in detail what all the improvements are, and he will also show how this will help to increase your productivity in your daily business. So, let's wait for Marco. I assume that he will be live now in a few seconds. We will hear us later on. Thank you.
Good morning and welcome to the SCIA user conference for the public release of SCIA Engineer version 24. My name is Marco De Biasio, I'm product manager at SCIA, and I have the pleasure to show you some of the novelties that I've introduced this year and that have been briefly described by my colleague Jad. The first thing that I'm going to show you is the new construction stages capability of the software. This has been a development that was largely requested by many customers, and finally it arrived in the 64-bit version of SCIA Engineer. To introduce you this feature, I will go directly to the software, where I prepared several models in order to show you a bit how the feature works and why it's important to use it in some case. Let's start with this simple model of a multi-story building that I realized in a bidimensional environment. We have on the left the building that we are going to compute in a standard way, then without construction stages, and on the right exactly the same building that we are going to compute with construction stages. We will apply just self-weight, it's enough for our demonstration. But firstly, let me show you how to enable the construction stages feature. In order to do so, we have to go to Project Settings, and in the Functionality tab, we have to be sure the Construction Stages checkbox is enabled. And in case we want to use also the Material Modification feature, we enable also this option of Construction Stages. In this case, I already did before. Okay, as you can see, in the Construction Stages environment, it's well integrated in the new graphical interface. Into the input panel, there is this new entity, construction stages, that group all the commands needed in order to define the construction stages. We have then the commands to add and remove members. As you can see, there is just one command, but this one is able to add and remove both 1D and 2D elements that in this case are not present in the model. The same philosophy also for the support. Then there is one command to add each kind of support on nodes, on beam, on surfaces, and to remove it. And same philosophy again for the addition and removal of hinges. One command that can add all kind of hinges on all kind of elements. In case in the model there were also tendons, we would have add here other commands, other icon in order to add and remove the tendons. From the other side, into the master entity selector that normally is used in order to switch the load case, we have this new entity, construction stages. Through this entity, we can switch the active construction stages. Let's start defining the stages for this model. I will click on construction stages. The model is it's a building that we are going to analyze in a linear way. Okay. I have already the first construction stages that is proposed. I will add other three. 4 construction stages for what I want to show are enough because I want to build the 4-story one after the other. I do close, and now what I have to do is just to assign the element to the correct construction stage. In order to do so, I switch to the first construction stages. I go to add member, and I select the member that I want to add to this construction stage 1. Then there's 2 columns and this beam representing the slab of the building on the right. As you can see, as soon as I add something in a stage, these elements are colored in green. In case I would have removed some element, that would have been highlighted in red. This simple color code allows us to have a clear picture of what has been added and removed in each stage. When I move to the following stage, the stage 2, you will see that these elements that I added in the previous stage are now in gray because they are already present in the model. So let's add the second story to this stage. So I do add member. I select the second story. Okay. I do the same for the third one. Add member. Okay, and I can do the same also for the fourth stage, but in the fourth stage I will not only add the fourth floor, but I will add at once also the model on the left, so that it will compute it at once. Instead to do as I did before, then clicking on add member and after selecting, I can do also the opposite action. Then first I select, then I add, and the command works in both ways. I've also to add the support. So in stage 4, I will add the support for the standard model that appears in stage 4. Okay. And I go back in stage 1 to add the support of the construction stage model. Okay, perfect. So let's recap and let's see what we did. First stage, we build the first story of the model on the right. Stage 2, we build the second story. Stage 3, the third, and stage 4, the fourth story, plus at once the model on the left. Let's go to compute and have a look at the results that we will obtain. I go to calculate, enable construction stages, calculate. First step, of course, is the mesh calculation after the linear analysis that I didn't disable. And after the construction stage analysis run, as you saw, the computation of the stage 3 started after the computation of the stage 2 was finished. This is because, of course, the stage 3, before to run, need the information of the previous stage, and so on for all the other. Let's close and have a look at the results. Before to look at the results, I will just change the visualization setting in order to have both the structure in gray. Now I don't want to focus anymore on the adding removal of element, but I want to focus on the results. And let's have a look at the internal forces in these two structures. I want to have a look firstly at the bending moment on the slab. So I select this, I select internal forces. I want to see the results on the current selection for the stage 4 in which both structures are present. I will select the class that is automatically created for the two buildings and the SLS1 where all the coefficients are equal to 1, but in any case there's just self-weight here. I want numerical results for each member and I want the bending moment. Okay, let's have a look at what we have. As you can see, the results between the two structures are quite different. In the structure computed through construction stages, I see what I can also appreciate in reality. The bending moment on the different slab is not at all the same. The upper one is the less loaded. More I go toward the lowest slab, more I find bending moment in the slab. Why? This is because the slab that is at the bottom carry not only its own weight, but also the weight that is transmitted, the load that is transmitted by the above structure. And so, more I go on and less there is bending moment into the slab. On the structure on the left, instead, I find that practically I have the same bending moment in all the slab. Why this is because the structure is built at once, the load is applied at once, and so when I apply a load on the first story, the stiffness of the rest of the building contributes to carrying this load. Even if in reality there is not this stiffness above, because in reality this part of the structure is not yet built. And I cannot account this with a simple calculation, I can account for this with construction stages. I can see this also better if I go to visualize the normal effort in the central column. So let me select the central column, refresh, and you can see a bit why the results of before. The central column in the standard model, the model computed at once, practically don't transmit effort. And there is really low value of axial force in this. Instead, in the model built with construction stages, I have this transmission of effort from the top to the bottom through the slabs. We can see the same results also if we go to see 3D deformation. Then let me select construction stage 4 as before, class ULS, SLS, and refresh. And here again, you can appreciate the difference between the two strategies of computation. In the model on the left, practically the same behavior at each story. The displacement is uniform along the height of the central column. On the model on the right, we can see what we can appreciate on the site in construction reality, that the slabs are not loaded at all in the same way in this kind of configuration. So already with this simple model, we can put in evidence how taking into account construction stages can be important while simulating the behavior of structures that are built on site on multiple steps. Perfect. Now let's move to another example of a building a bit more complex in geometry, where I also will put in evidence difference in behavior between the computation with and without construction stages. In this model, the two structures are equal, loaded in the same way, and the structure on the left, we are going to compute it through standard calculation, so at once. The structure on the right, we are going to compute through construction stages, so we will compare the difference. Let's have a look at the stages that I prepared. In fact, I already computed this model in order to save time. Go on the construction stage, and I will show you the strategy of stages that I used. In the first stage, I built the first story. In the second one, I built the second story, and so on. So the third, the fourth, the fifth, the sixth, and after the sixth, I build at once the building on the left. So then I applied also variable load. Let's have a look at the results that are obtained. As before, I will change the setting for the view, and I will put all the visualization in gray, so to focus on the results. As first, let's have a look at the resultant of the reaction in order to be sure that the load that I applied in both the cases is the same. I go to select resultant of reaction. I select all the support of the model computed in a standard way, so current. I go on the stage wall building, then the stage in which this building on the left is built at once. So in this case, we have self-weight for both the structure only. The class is the same. I refresh, and let's have a look at the value. It's around 9,917 kilonewton. Let's go to see for the other model. Refresh. It is again 9,917 kilonewton. So I have the same reaction because I have the same load on the structures. But let's have a look now at the reaction, because it's true that the resultant is the same, but are them distributed in the same way? I will select all the support of both the structures, reactions, the class is the correct one, vertical reaction, refresh, and let me move in wireframe visualization so to have a clearer view. Let's compare some of this value. As you can see, the numerical value are quite different. Here for this column I have 319, here I have 297, here I have 508, I have here 458, and so on. Even if the global resultant is the same, the distribution of reaction is different. It means that the distribution of internal effort through the structure is different. And let's have a look at some other results in order to highlight these. So if I go to look, for instance, at the deformation, I can select, for example, this column and this one, and also the column close to the core walls here. And I want to see on these columns for the stage in which both buildings are present. so the class associated to this stage. I want to see the deformation, the axial deformation, then ux in a member coordinate system, because x is the axial axis. I want numerical value for each element. For better clarity, I will hide everything it's not selected. I will refresh, and as you can see, immediately you see that the numerical values are different. But also the distribution, the shape of the graph is different. On the model computed in a standard way, you have this smooth groove of deformation from the top to the bottom. In the model with construction stages, no, there is the discontinuity at each story. Of course, because the strategy of computation is different. On the model on the left, the computation is done at once. On the model on the right, the computation is done step by step. After the first story has been built, the deformation is set to 0, and the story above is applied with its own load, and so on. So the behavior is not at all the same. And we can appreciate this once again if I visualize everything and I go to see the 3D deformation, always for the stage with both the building, the correct class of results. I will put in wireframe to compute quickly. Empty selection, of course. I have to select all. Refresh. Perfect. As you can see, the deformation on the two structures are not at all the same. We have the same load, the same geometry, but we have not the same distribution of effort, we have not the same distribution of deformation. And as you can see, the model built with construction stages represent more reality that we can encounter on site, where the deformation are much less than what we can compute with a model without construction stages, and that is be computed at once. So once again, take care when you are going to choose a strategy for the simulation of a building that is built in several steps, because the choice of the strategy can have really a drastic effect on the results that you are going to have. Perfect. After this, let's move to the next topic that I want to show. That is the new nonlinear analysis for reinforced concrete structure. In SCIA Engineer version 24, a new behavior law for reinforced concrete has been introduced in order to take into account the cracking of the concrete and then the following reduction of stiffness of the material. I will show you directly again in SCIA with one example that I prepared, but before let me just close this model so to make a bit of free RAM on my laptop. So this I'm not going to use anymore. And let's focus on this model that I prepared to show you the nonlinear material behavior of concrete. As I did before, I put twice the same structure in the same model. The structure in this case it's a simple reinforced concrete beam. We can see it. I already put reinforcement the same in both the case. Then the two beams are exactly geometrically the same with the same reinforcement, the same load and the same boundary condition. We can have a look at the load that I applied. So I have a variable load that is this one distributed plus permanent load that is distributed along all the beam plus a concentrated load in this point. And the only difference is that the beam on the bottom is computed in a standard way with linear behavior of concrete. The beam above is computed with the new nonlinear material behavior law for concrete. First of all, I will show you how to activate this functionality. In order to do this, always in project settings, in the functionality tab, one has to switch on the reinforced concrete material nonlinearity case here, as I did. Okay, and to apply the new nonlinear behavior to the beam above, we have to apply this material behavior to the material that constitute the beam. The material, as you know, is associated to the cross section. So, for instance, if I go to select the linear beam that I already prepared here, I set the beam and I go to see its cross section. Here you can see material 5060. if I do edit in order to enter into the material, the detail of the material, I see that the material behavior for the analysis is set to elastic. In the beam above, instead, the difference is that the material is set to isotropic damage Mazar's law. Let's have a look at that more in detail. So I go to select the beam nonlinear, and as before, I select the cross-section that I call in this case nonlinear. And as you can see, I put the same material C5060, but I called it nonlinear in order to make the difference. And if we go to have a look at the detail, the material has the same characteristic, but here I selected isotropic damage with the law of Mazars. Once I've done this, I have other option. I could consider creep effect if I want. I can specify if I want or not the tension part in the stress-strain relationship. And eventually, I can also have a user definition of the stress-strain relationship of the material. So I can, through a table, specify the material behavior law by myself. Of course, I can have a look at the material behavior curve that is obtained. In this case, as you can see, I've selected to not have the tension branch, but of course, if I switch on the tension part and I go back, I will have also the tension part. I set it as it was before and I close. Of course, nonlinear material behavior can also be associated to reinforcement bars. There are available elastoplastic law with or without kinematic hardening for this model. So I said OK, and I go to compute the model. So calculate, nonlinear analysis, calculate. Dimension and linear analysis are starting, and once they have done, the nonlinear calculation will start too. I have only one nonlinear combination. In general, this kind of material behavior law requires some iteration, so it can take some time, but as you will see, it is reasonable and the computation progress quite quickly. You are almost at 50%. It's very fast. The convergence of the model is really good, I have to say. Of course, I add that this material behavior law for concrete is available not only for 1D members, but also for surface. You can model whichever structure in SCIA and apply this behavior law to concrete of surface, walls, slab, a beam, columns, and so on. And of course, I add that in order to have convergence of this law, you have to have a reinforcement in the elements, because without reinforcement, the convergence is very difficult, because as soon there is tension in the structure, there are not any more elements able to carry the load. But instead, if you have reinforcement, the effort is transmitted to the rebars, and so the convergence can be reached. So the computation is done. Let's have a look at the results. I want to show the deformation, and let's see if there is some difference in the two beam. I will go to look at the result for the nonlinear combination, so I will have result for nonlinear analysis for the upper beam and for linear analysis for the lower one. I'm interested in vertical deformation, so in global coordinate system. Let's refresh. As you can see, the results are not at all the same. The beam that is modeled with nonlinear material experience a deformation that is more than 3 times the one that is experienced by the linear behaving concrete. So the difference is very large, and it can make you understand how one should be careful when decide to analyze a structure with one model instead than another. A lot of users asked us to implement this kind of nonlinear material behavior because they experienced when they were going to analyze existing structure that the result issues of calculation were very different from what they could measure in the reality of the site. Why? It's because the structure is cracked and it's not anymore as it was when it was new. So this is really a material behavior that can give you something more for specific project. Perfect. Let's move to the next and final topic that I want to show you. That is the automatic mesh refinement that has been introduced in SCIA Engineer version 24. Let's move again to the software. I will close this model and I will show you the model that I prepared in order to illustrate this new feature. I modeled here a connection between a beam and a column, and I modeled it explicitly. So I created some plates and I put a rigid link in order to connect the elements here, the plate of the beam to the column. The load that is applied is this one, so a vertical load on this part of the beam. And what I want to show you of this new feature is how it can be useful in cases like this. Why? Uh, in a simulation like the one that I want to show you, what I'm interested in is to have the results that are the most accurate as possible in the part where there is the connection. When I say most accurate as possible, it means that I want to take well into account all the effect of intensification of stress that we can have due to the geometry of the problem. In order to do so, as you all know, the only way that we can use is to make a finer mesh. The problem is that if I do a finer mesh everywhere, it's one useless because to have a very fine mesh in the upper and lower part of the column or here far in the beam doesn't bring me accuracy where I want. From the other side, it's also something that increases the computational time. So what I would like to have is to have really a finer mesh all in the place where it's needed. That it's all in the place where I have the most of the stresses. And it's exactly what this new algorithm of refinement of mesh is going to do. In order to use it, it's very simple. When one wants to run the calculation, in the advanced mesh setting, one can specify use automatic mesh refinement, as I did here, and also has to specify the target error for the mesh. For instance, let's say that I want to accept maximum 15% of error. I should after select with respect to which load cases I want to optimize the mesh, because of course the optimal mesh will be function of the applied load. So here I have just one load cases. I select just this one. If I had more, I could select more. I do OK, and I calculate. The computation started with the mesh calculation, and now several iterations are done on the mesh itself in order to find the mesh that fits the target error that we specified. It can take some moments because there are more iterations, but as you can see, again, the progress is quite smooth and fast, so it's really reasonable. Computation is almost finished. Perfect, it's finished. Close. And let's have a look at the mesh that has been created. I go to enable the visualization of the mesh. Okay, and as you can see immediately, the refinement of the mesh is there where we could expect. So there where we have the most of the stresses and where there is more intensification of stresses. We can see this better with the specific results that we have for mesh refinement. It will give us a color map that will give the dimension of the mesh that has been used. And as you can see, the optimization is really only there where it's needed. We have not optimization far in the beam, far in the column, but only in the place where it's needed. So in here and here. And this, as you can imagine, it's a tool that can be very useful for the user that do this kind of modelization, mostly in metal, of let's say mechanical details, because can improve the accuracy of the results without really effort on the side of the user, because the user just need to select target error and apply the loads, and after that, the software itself will compute the optimized mesh and will use it for the linear and nonlinear calculation that will be done. Perfect. With this, I finished my part of the presentation. I show you everything I wanted to show. I thank you for the attention and I wish you to enjoy the rest of the presentation of the day. Have a nice day. Bye.
Yeah. Okay. So, thank you, Marco, who's sitting somewhere. Thank you for all the explanations. And actually, thank you to all attendees that we can find a lot of questions in the chat. Actually, you see, I got 2 of them right now, and I have Michele with me, one of the teammates of the product team, and Michele. Let's try to answer to 2 of them.
Okay.
First one, can you influence the young modulus of the concrete in the different phases?
Yes, as we had it in a different way in the previous version of SCIA, now it has been redeveloped and is a little bit more powerful. We can create modification groups that you already knew from version 22, and with those we can influence almost every element of the structure, 1D and 2D in every stage.
I have to believe what you were saying, but
yeah.
I think it was...
Users know what I'm talking about.
Absolutely, absolutely. Great. Second one is there a limitation on the size of the mesh using the automatic mesh refinement?
Yes, that will be based on the general mesh size that we give. So in that case, also if you, let's say, push the analysis a little bit further, there will still be a mesh limit. So you can keep using the new tool and have really great information on your models.
Okay, thank you for that. I'm always, to be honest, I'm always impressed by this huge competence you and your team are always delivering. It's I don't understand anything from this, but that's good to know that you can answer to those questions. And actually, I can just repeat myself. All the questions will be answered later on. We have a bunch of questions, like very a lot. Thank you very much for this. It's great to see that you're participating. Thank you for that. Now, do you have questions, actually?
What's next?
What's next? Okay, that's a good one, actually. We're coming to our third point. And the third aspect of our conference is somehow you, dear partners, dear users, because as I highlighted already in my introduction, your feedback and your insight that you're giving from your daily business to our departments is very, very important for us. And I thought already that somehow most of the new innovation and all the new features that we are trying to develop is based on the feedback from our customers. And now we have Yael, as announced, with us, who's sharing with you the news, because we have crafted a dedicated product portal for you, as already requested for several years. And she will walk through it and show you how you will benefit out of it. Enjoy.
Hi everyone and welcome. I'm Yael Verkammer. I'm a product manager at SCIA Engineer and I'm responsible for the developments in material design in our software. I will present to you the voice of the customer part of our presentation. Every year, we send out a customer poll to our users, and we promise to implement the top 3 voted features into the next version of SCIA Engineer. We have done this a lot of years by now, but unfortunately, this year is the first year that we did not manage to implement the top 3 items. Unfortunately, the second feature in the list, we haven't been able to implement it for this version, and we hope to implement it for the next one. To compensate for your loss, we have decided to also implement the fourth and the fifth voted item in the list. I will now present to you these 4 items that have been developed. The first one, which had clearly the most amount of votes, was a relative unit option for the SLS check. We have implemented this option for the Eurocode steel and Eurocode aluminium checks. And if it's very popular, hopefully we can extend it in the future. You will find it simply in the SLS check for steel or when you choose in the values, you will find the normal values as they usually were displayed in millimeters. And under it, you will find the same with the little rel notation after it standing for relative, where the deformations will be displayed in a 1/something format, in the fraction format. So instead of just seeing the millimeters of deformation, you will see the millimeters of deformation divided by the length of the corresponding beam. This format is useful because at once you can easily see whether it is under or over the limit and see exactly how much the deformation of the beams is in just one picture. If you prefer to see this format in a decimal format, you can also change it in the units from the fraction to the 0.something format. But yeah, the default is the fraction format. Not the second, but the third voted item is some improvement for the load case selector. Previously, it only displayed the name, and now the description has also been made visible because a lot of our users actually use the description to really describe what load case it is. The field has therefore been enlarged to allow to display the longer names, and it will automatically scale with the size of the window. We hope that this will make it easier for you to find the load case you are looking for. The fourth option was an option for 2D concrete design, where in the template previously it was possible to vary over a diameter for finding a solution or vary over spacing, but not to select some specific sets of diameter and spacing combinations. That is exactly what we have now developed. In this dialog, you can add specific diameters or specific spacings as options, and then from all of the combination options, you can select with the combo boxes which one you want to actually consider for the design. Of course, you can not only add, but you can also remove these diameters and spacings by removing them from the list of options. And finally, the fifth developed item is a restraint by sheeting option for non-symmetrical cross-sections. This option allows to perform a check in the local axis of a cross-section rather than using the principal axis, which is the default that is always done. When would you use this? For example, if you have an L-shaped section that is against a wall or restrained by some sheeting, as the option is called, it will not be able to move in the direction of its principal axis, and therefore making the check in this direction doesn't make sense. So now, if you activate the restraint by sheeting option, then the properties of the local axis will be used and the check will be done according to the local axis of the cross-section. Also in the output, you will get a note that states that the check is being done according to the local axis system because this option has been activated by the user. This can help you make slightly more economical design in these use cases. Aside from a customer poll, which we will still be sending out, we'd like to collect more feedback from your side on the features that we are considering to develop. A while ago, you have already received, if you are a client of SCIA Engineer, you have already received a link to our portal. And yesterday, a mail has been sent out again to invite you to join us on the SCIA Engineer user portal. The features have been updated to our current release, so you will see new items that are in progress, new features that we are considering for development. Of course, we don't show all our cards. Not every feature that we are considering is shown on the portal, so don't be scared if you don't find your feature. And in the top right corner, you have the Submit ID button where you can always submit your own ideas if they aren't visible in the portal. So on this portal, you can see all the features we are working on, and you can leave behind some comments and some votes on how important these features are to you. While developing, if we need some feedback, we could maybe contact you to ask which way you would prefer to see this feature implemented. And of course, we can send you updates on the features you have voted for when they are going into development or when their development is being finalized. So I hope you are all going to join us there and voting for your favorite features. With this, I thank you for your attention and I give the word back to the studio.
Good. Again, thank you very much, Yael. So now you know everything about the product portal, and actually, I just wanted to refer to your questions, and of course, again, thank you for putting them in the chat. That's great. Actually, at the same moment, we do see some raised hands. We cannot have somehow this included now in this session, but please try to put your question just in the chat. We try to answer it as fast as possible. So that would be the perfect way now to include your questions to the audience as well, because we cannot talk live here if you raise your hands. Now I'm handing over directly to my dear colleague Manuel. Manuel is presenting something that you had given as feedback in the past, and this is something, as I told you already several times, we have listened and we are listening to your feedback, and now it's all about the connectivity between SCIA and our sister brand Frilo for foundation calculations. So, Manuel, the stage is yours.
Welcome, ladies and gentlemen, to my presentation about the SCIA Frilo Foundation link. My name is Manuel Walter. I'm the head of product management for Frilo and DC, and I'm located in our head office in Stuttgart in Germany. First of all, I would like to give you a short introduction about Frilo and about us. Frilo offers software for structural engineers for component-oriented design and calculation of structures. That's the main difference between Frilo and SCIA Engineer. SCIA Engineer is a 3D multi-material finite element module, and on the other side, Frilo software offers those tiny little component-oriented modules just calculating single components. Frilo has more than 25,000 active users, distributed around 62 countries in the world. As I already mentioned, we do have a big bunch of different tiny modules calculating components, and the total number is more than 170 at the moment. We have more than 70 employees located in different offices around Germany. And at the moment, we are counting around 300,000 active licenses distributed amongst our customers. Besides the foundation link, which I would like to present you today, we offer a lot of other different links which are already existing between SCIA Engineer and Frilo. One of these already existing link is our masonry link. So we are able to hand over masonry walls from SCIA Engineer into the masonry module from Frelo directly and do a proper calculation and design of masonry walls there. Of course, we offer the foundation link, which is the topic of today. And furthermore, we have a link to calculate timber truss joints using our module HO13+. The most important link at the moment is that one between our building model and SCIA Engineer. In this way, we are able to exchange data for 3D building models in a bidirectional link. We can use the complex calculation in SCIA Engineer, or we can use the component-oriented design on Frelo side by just handing over the entire building model and cutting out single components on Frelo side. Of course, we are working on some further links. We are concentrating on the workflow for reinforced concrete at the moment, and therefore these are our next projects to come and next links to come. First of all, we are concentrating on the reinforced concrete columns. After that, we would like to offer more direct links, for example, dealing with reinforced concrete slabs or plates, and dealing with a punching shear analysis. Besides that, we would like to offer a link to our continuous beam solution, and later some more geotechnic solutions like strip foundations or pile foundations. But now let me start with my presentation regarding the foundation link. Let's have a look on the initial model in SCIA Engineer. I've calculated a multi-story building which consists of a several number of main columns. It's a 5-floor building, and we do have some core walls for the bracing, of course, for the horizontal loads or wind loads. And in the initial state, we do have hinged bearings at the bottom of these shown columns. As a first step, I already modeled some different pad foundations. SCIA Engineer offers the opportunity of 2 different types of foundations. So there could be a standard pad foundations, like the right one, or there could be a pad foundation with an external bracing as an alternative. Both can be modeled in SCIA Engineer directly. So that means you are able to set up their geometry directly in SCIA Engineer and to take their weight and their boundary conditions into account during the calculation. Besides that, you have also the possibility to define the subsoil parameters in SCIA Engineer directly. Different subsoil types are available there. So there is a decision or a differentiation between cohesive soils and loose soils, and their dedicated parameters need to be defined. After that, of course, we need to run the calculation again because we changed the boundary conditions of the entire model, and we need to run the calculation therefore to get all the loads which should be applied on the foundation. After the calculation, we could, for example, display the reaction forces in the bottom or in the foundations or in the bottom nodes of all those columns. To find the most unfavorable load combination, it's of course not only regarding the normal forces, but in the end it's always a combination between normal forces and eccentricities. Those eccentricities may come from horizontal forces or bending moments, of course. If you are not sure which is the most unfavorable foundation, my suggestion would be just hand over a couple of them, and then you can decide according to the calculation in the Freelo module which is the most unfavorable one. Before handing over the foundations, they need to be defined as a first step. The function behind that is called Freelo foundation input. So this step needs to be done as the initial step, because otherwise the link doesn't work. For that, just select all pet foundations you would like to calculate and assign a dedicated name to it. By assigning that name, you make them available for the direct link and for the export to the Freelo module. After all these foundations are named for the export, the next function you need to find, and you could even use the search function, is named Freelo Foundation Check. That's the main function to run the link and to run the foundation calculation on Freelo side directly. Before you can hand over all the necessary information, you need to select the type of load and, if relevant, select the type of combination. After all these settings are done, just press the Export to Freelo Foundation button and the Freelo Foundation module will run automatically. But first of all, you need to define the type of loads you would like to hand over. FD Plus offers two different calculation modes. The first possibility is using design combinations. The second possibility is using characteristic load cases. The design combinations are built by SCIA Engineer, for example, by choosing the automatically built combinations like the ELU ZB, for example. If you would like to hand over characteristic load cases, I would suggest to create a user-defined result class and include all the single characteristic load cases there. In this case, you can just hand over those result class containing all the characteristic load cases. But why is it necessary to have these two different types of loads to hand over to the Freelo Foundation module? So in the end, it's something special in geotechnics. So the geotechnical engineer and the geotechnical calculations are based on specific approaches. So in the background, we often use different safety factors. We often use different ways of calculating it and of building the combinations. And that's why my suggestion would be, if nonlinear calculations and additional internal forces according to theory of second order have a minor input on it, just hand over the characteristic load cases and make the foundation module to build the proper combinations itself, because it knows how to build them and how to steer the different checks that need to be handled. When the selection for the type of loads is done, just type on the Export to Freelo Foundation button and then choose one of those foundations which are shown below. After that, you have to choose whether to hand over internal forces or reaction forces. And after that, the Freelo Foundation tool runs in the background automatically. Let's jump to the foundation module itself. This is how it looks like if you hand over all the available information initially. As you can see, the geometry is already there and it is according to your definition in SCIA Engineer. So all the geometric information about the foundation plate and about the embracing is already there. In this case, I handed over characteristic load cases, as you can see in the load table down there. There are 3 different load cases in the SCIA model. First is the self-weight of the structure and the foundation itself. Second, other permanent loads, and third, variable loads. Of course, we can have way more than those 3. In the end, the amount of combinations increases exponentially with the number of characteristic load cases. As a standard setting, we use an auto calculation in the Freelo modules, which means that in the background, the model runs automatically after any change. There's a preview about the results in the user interface as shown on the right side of the screen. And we can see the utilization factors immediately. As we can see, in this case, the settlement calculation and the ground failure calculation are not fulfilled. So that means we need to react on that and change the geometry of the foundation until those checks are fulfilled. We may run an automated optimization, but in this case, I just would like to change the geometry manually. As you can see in the background, the calculation runs automatically, and by just increasing the foundation length from 1.5 to 2.5 meters, all the checks are fulfilled. As another possibility, I could just run the automated optimization, and the algorithm tries to fulfill the most unfavorable check in the background and to get an utilization factor nearly to 100%. Once that is done, you can just go back into your SCIA Engineer model and adjust the geometry according to the dimensioning using the Freelo module. Of course, we offer a lot of possibilities of reinforcement design for the foundation as well, once the geometry is fixed, and to have a proper design and calculation for the foundation. In the end, if all the settings are done and the calculations are run and all the checks are fulfilled, you will get a reinforcement drawing or a reinforcement sketch showing all the necessary reinforcement to fulfill the reinforced concrete design as well. That's it from my side. Thank you very much for your attention, and I wish you a good day. See you. Bye-bye.
Okay, let us check if everything is okay. Free sign. Great. Okay, so we are coming to an end. So first of all, thank you, Manuel, for the presentation. So as you're used to, we are handling some questions right now. So you see me surrounded by 2 dear colleagues, Lisa, that you don't know yet, and Michele, that you have learned about him before. So I was handed in some questions, so I tried to read them, and some of you are answering to those. So let's start. First one is there going to be another customer call this year? And when can we expect it? Who's going to answer?
It's a very good question. Of course, we are going to have another customer poll because we think it's a very good tool to know our users' opinion and to really implement some things that we know that they really want. So, of course, there's going to be another one this year, and it will be sent out somewhere in May or June.
Super. Okay. We know that everyone is eager to participate, and we are really having great answers out of this. So please continue to do this. Second one is how is our feedback on the portal processed?
Yeah. So I'm going to answer that as well.
That's also product question.
Yeah. So we very much appreciate anything that is inputted on the portal, being voting for existing features that are mentioned on there or submitting new ideas. And the product team is really handling it constantly. I would say weekly. Every new inputting idea is looked at by the product manager that is responsible for certain area, for the area for which the idea is intended to. And it really helps us to get a good idea about what our users need and giving that overview with all the votes for the different features. So if you don't have access actually to the product board portal already, please reach out to the support team and you will get it. But all of our users should already have access. So if not, please reach out.
Good, thank you. Great. Okay, next one is it possible to use non-linear analysis of concrete structures when undertaking CDD?
Yes, so CDD is long-term deflection.
What is long-term deflection? Now, go ahead. Go ahead.
So, first of all, I want to mention that we received a lot of technical questions. Thanks for the feedback, and please reach out support and product team to mention this question so we can look forward to answer and see the challenges that you have. And to answer the question, yes, it's now possible. So now we can run also nonlinear calculation, nonlinear combination for the CDD analysis. So now you can proceed with that, and with our new solver manager, it will be a lot easier to run really high-level calculation. Let's say it like that.
Okay, good. Thank you. So next one is, in which edition is the construction stages functionality included?
That's one for me. It's a very good question. Actually, we recently reviewed the edition structure. So in this case, the best approach is actually to contact your account manager so we can see what's the best approach is in your case.
Mm-hmm. Okay, good. Good. So, do you want to add something?
Yeah, I can add last things. As I mentioned before, the support. We have also a lot of training webinars. I want to highlight mainly that you can find all group training and personal training on our website. You can always contact us if there's any new specific topic that you want that we look at it together. And as mentioned before, we really look forward that you use a new user interface, and Lisa will help you, and we will help you as well with the support to use it. And please give us your feedback, and we will find. We have already the solution, but of course we need to show you how to use it properly. So, Lisa.
Anything from your side to add?
Yeah, I mean, we have a lot of material as well that will help people to really get to know our software and all of the functionalities. But if there's any other way we can help, like Michaela said, please reach out, and we are very happy to help.
Good, yeah. Well, this is actually a good point, right? So the training sessions, and from our side, I would add somehow that we are strongly recommending to have somehow a training at least every second year, because as today we are launching so many new features, new functionalities, new innovation, that to be updated and just to get the news, this is something that we are heavily recommending. So that's good to mention, of course.
Yeah, exactly. And we are not limited to what you see on the website. You can reach out and we make it a la carte, as we say in France.
Good. Okay. So, as my dear colleagues already told, we are already here, or always here, to assist and to support you. So please feel free not only to reach again out to ask a question, to have different, whatever it will be, technical questions, support functions, etc. So please reach out. So we are at an end. Thank you very much to all presenters, everyone who has prepared something, and everyone who has presented here today in the last 2 hours. I'm very grateful for that, for all that support, especially the technical one. and we do have such a lot of competence within the support team. Please just use it. And yeah, this is now the moment to also thank a lot to our technical team in the background. You don't see them there, but it's time to have a small applause for that. Thank you to make it happen, and thanks to all of you. Thank you for your trust. Thank you for everything, and see you very soon. Enjoy your day. Have a nice afternoon, and then bye-bye.
Download the
Download the version 24. Exactly. So, thank you very much. Bye-bye.
Bye.